Hello? Hello, everyone. Can you hear us?
Okay.
Nice to see you.
From me?
I
Yes.
will start by first introducing us. I'm Marco with Andrea Romeo. We work at TeamSystem, which is an Italian tech company that builds products for micro businesses, small, medium enterprises, accountants, lawyers. So we have around 200 products in Italy, France, Spain, Turkey. And Andrea and I are part of the data platform team, which we build features directly for the end users of our products. But today we are going to tell you a bit more about something we have worked hard in the last months, which has made really us work hard and suffer. So I'm glad to share with you today. So this is a simplistic view of the problem we had to face. We are talking about MailUp, which is one of our products, which is an email marketing platform. We have this architecture on the backend side. So we have an app that exposes APIs to end users, but for each customer, which is a corporate customer, we have a dedicated database. So we have a database per tenant model. So we have the exact same schema on each database dedicated to each customer. And we have a master database where there is just some master reference data to say for customer A, you have tenant A, customer B, tenant B database. So this is our source data, but the need that we have is to do some analytics and aggregation across all the customers of MailUp. So the idea is that on our data lake, we have for the same table, which has the same schema across different databases, a single table with the records from all customers, so that you can do aggregations among them. So today we are really focusing on how can we do as a data engineer efficient ETLs. What you can think of that comes first to your mind can be something like this: a batch job that starts every day, like at midnight, then makes a big for loop over all the table one across all source databases, then takes the updated or new records in that table, and then appends or updates the record in the target data lake. So this is something that we have considered, which has some limitations. First, when you start and when you have a high number of tables or a high number of customers, we are talking about tens of thousands of customers, you can have some impact on the main OLTP database, even if you do it during night still. Then performance. It takes time to do this big for loop over and over. And then you have latency, because you have data updated at most once per day, plus some delay. So today we are really thinking, how can we improve this approach? How can we do something that is tackling these issues? To give you a flavor of what we started from, what do we have as a data engineers as tools? We know how change data capture works. So you can use tools like Debezium to listen to transaction logs of a certain table and being notified when there is an event for any record in the table. Then you can decide what to do with this event. For example, you can write it to a Kafka topic, and then you can manage all these events and write them to your data target. But the issue is that this, in theory, improves what I discussed before, because in theory, you reduce the impact on the database because you don't have these repeating poll queries. In theory, it should be close to real time, and you have something that has no latency, in theory. But this was not working on our side. I mean, it's a bit more complex, because you don't have one table, but you have thousands of tables span across different databases with the same schema, but on different databases. Plus, whenever a new customer arrives, there is a new database dedicated to it. So you have to handle this. And then there are also some DevOps or SRE operations that the operations team is doing. And sometimes they want to move a database from a server to another. So this has more extra complexity. So today, I will introduce you to a solution that we designed to tackle these challenges. That is, I will give you a really high-level overview, then Andrea will go more in details. The idea is as following. First, to have a change data capture job that is notified by the events that occur on the master database. So we are notified whenever a database is moved or a new customer comes and a new database is created. These events are processed by a GitOps services via Argo CD, which is responsible to dynamically span or destroy the Debezium instances that collects data from different tables. This is a really high-level overview, and now in this talk we will go a bit deeper to how it works, what are the challenges. Okay. So I will leave the stage to Andrea. Let's start from the bottom part of the architecture.
Thank you, Marco. Thank you. And I just start with an introduction of the two main tools, because I will stress you just with the two introductions of two tools which will be the basis for this presentation. The first one is, I'm pretty sure that almost all of you already knows, because it's really fundamental for the near real-time analysis in data engineering. But we need to keep in mind, I want to introduce it because we need to keep in mind two principal key points. So what actually does change data capture? I want to focus on the SQL Server, because this is a feature that you can find in almost all of RDBMS. In SQL Server, you have always a technical table, which is this transaction log. And inside this transaction log, you have all the information about the operations of update, adding, deletion, of everything inside your server. And when you activate and the change data capture, it's a feature that you can activate with the store procedure on the server and for one database. And when you active the change data capture, essentially you are activating two jobs. One is the capturing jobs, and it is always up and running. And essentially it is reading from the transaction log, and it tracks all the information of your source tables and store these informations in these technical tables, which are the change data capture tables. The second job is the cleanup process, and which is a technical job that cleans. It is scheduled, and sometimes it cleans all the old logs inside the change data capture tables, because you want to avoid the filling up of the memory of the SQL Server. And so keep in mind these 2 points, that you have one job always up and running. And the second, that you have one scheduled job. The second tool that I want to introduce here is Debezium. And Debezium is really, really, really powerful when you use it with change data capture. And actually, indeed, in SQL Server, when you're managing SQL Server, you need to have the change data capture active on the database that you want to track the information. How Debezium work? Debezium, the first step is to take a snapshot of the change data capture tables, of the source tables. And then it starts to track all the changes about these tables. And it starts to read from the change data capture table all the changes, all the operation of updating, adding or deletion of rows. And essentially, it extracts one message, and it extracts one message and sends this message to some Kafka interface. In our case, we have an Event Hub, but the Event Hub is more or less the same of a Kafka in the Azure world. But the main point is that you can send with Debezium, you can extract and build a message as you want, and you can send this message to some Kafka interface. let's here I just put some the configuration file because you have to define one Debezium instance for each server, and you need one configuration file, and you can install Debezium on each on a Kubernetes cluster, and in this configuration file you have several technical fields and some technical fields about how you want to extract and build this message. But I want to stress the attention on the field that you need on database.names field, because in this configuration file, you need to list all the databases that you want to track inside the server, and you can't use a regex pattern. So if you want to add a new database in your tracking with Debezium, you need to add this database in this line. Here I just put an example of the message of the JSON of the JSON that built from Debezium, and you can see here we have an example of an update operation, and in this case you can see that this JSON it's we have an example of an update because we had an update of a row inside one database, and one field of an LDB server has changed, and now we have another field value, and that's an example. So you have a before node inside the JSON and then the after node. It depends on the operation that you have on the database, but I mean it's very similar for addition or deletion of rows. So let me move on in the core of this presentation, and I just want to remind you that we have our infrastructure is more or less 15 of servers, and inside of each server you have more or less 1,000 of databases, and for each database represents one customer, and each database has always the same structure. So you have always the same source tables, which are, for example, dbo.subscribers, and you have always the same structure. What we want to do is to bring all these data into only one table, and because we want to collect all this data is only one table because it's easier for our data engineers to make analysis on one table, and so the target data, and then so we have one unifying table, and we want to analyze with some workload with Databricks, so it's simpler. And so what we decide to do is to create one topic for each table, one dedicated topic, and so the source tables and the target data is the Kafka topic, and what's there in the middle? In the middle there is a Debezium configuration. I mean, we have one Kubernetes cluster, and we set up one Debezium instance for each server, because remember that you need one Debezium instance for each server, and so also you have one configuration file for each Debezium instance, and we stored all these configuration files inside one GitLab repository, which is linked to an Argo CD instance, and I don't know if you know what is it, but essentially it's a continuous integration and continuously delivering tool for Kubernetes application. So when you receive a new changes inside your GitLab repository, Argo CD automatically takes these changes and applies these changes on your Kubernetes cluster. So everything, it's done more or less automatically. And so you have one Debezium instance for each server, one configuration file. Just remember that in each configuration file, you have this field in which you need to list all the databases names that you want to track. And as Marco showed before, the infrastructure, I mean, everything. It's quite easy because you can think that it's easy, but all the databases inside the server, it's changing quite often because each database is one customer, and if you can think that if it depends on the business that you have, but you can think that in one day you can have more customers. You can add some customers, or the volumes. It depends on the business, but you can imagine that you have a lot of customer more or more customers less, and each customer more is one database is added in your list that you need to track. Sometimes, moreover, all this server has to rebalance the number of databases that it has inside. So sometimes also if you don't have a new customer, sometimes it happens that one database change the location from one server to another, and it's quite complicated. So you need to understand how to manage this changing of location of databases. But we have one special server, which is the master server, and inside this server we have one database with one table in which we have all the information about the location of each database. So imagine that you have one column with the database name and one column with the server. So you have a lot of changing, and assuming that when customer is added, it's the adding of a new row inside this database. And also, if one database moves the location, it's an update of a row in this table. So what comes into your mind, I think, but it's quite straightforward to think about this, it's to configure another instance of Debezium for the master server, and is exactly configured in the same way of the standard Flowe. So when we receive an update operation, so we activated the change data capture inside the source database. When we received an update operation on the change data capture with the change data capture feature, we extract and we build up a new message, and we send this message to a dedicated Kafka topic. But at the end, we don't have a Databricks workload, but we have a fast API application, and it's quite interesting to see what this application actually does, because it's the core of the manage of this all of this architecture. And so we receive for example, assuming that we are adding a new customer, we are receiving a new row and the adding of a new row on a new database. So the first thing to do is to activate the change data capture on the right database. So because remember that you have all the information that you need. So you have the database and the SQL server. So you can find the right server, and you can activate the change data capture. The second step is to pull the GitLab repository in where you have stored all the configuration file for each Debezium instance. And you can find the right configuration file for the right server, because you have one configuration file for each server. So you need to find the right one. And you can update this configuration file, and you need to update the database.names field list, and where you need to add the new database. Then you can commit and push these changes, and automatically Argo CD will take this changing and applies this changing on the Kubernetes cluster. So in near real time, you have all the information updated like the reality. So here we have an example of the commit that FastAPI did. For example, here we we have added one database in the database.names list. So everything went well. I think we made all this in the test environment, and everything went well. Everyone were really happy because the infrastructure also is pretty interesting to present. But the problem was that the test environment was pretty different from the production environment, and we have really different volumes. And for example, in test environment, we have only 2 servers with just 300 databases for each. I mean, one is the master, one is the standard. So we received some deadlocks when we tried to elevate this in production. The problem is just to remind the number we have in production. We have more or less 1,000 of databases for each server. So if you activate all the change data capture inside, you have 1,000 of jobs continuously running. And so if you want 1,000 of jobs continuously running, you need to have 32 processors, more or less, and it's really expensive. So we stopped this development. We just need to find a solution. And the problem is the always running capturing jobs, because the default configuration and the recommended configuration for SQL Server is to have these jobs continuously up and running. But you can change this configuration, and you can schedule all the capturing jobs. But you need to pay attention on 2 main problems. One is that if you schedule and if the capturing job is not fast enough, you can lose some data, because there is also the cleanup job. And so sometimes it happens that the cleanup job can clean the data, and so you can receive some conflicts, because if you lose data that you don't have read, you can have some problems. The second is, so you have to schedule really close, but you need to avoid concurrently jobs, and you need to avoid the overlapping of scheduling jobs. So and also these databases are added randomly during the day, so it's quite complex to manage all these kind of problems. So, but I mean, the problem was, I think, that the solution I think it's quite interesting to do, but the problem is that we didn't have the right skills inside the team, because you need at 100% you need to be sure, because if you change those configuration in the SQL Server, you need to be sure at 100% of what are you touching, because these configurations are really sensible. So we lacked the DBA skills, and so we had more data engineer skills. So we decided to stop this development because it's quite complicated. But we learned a lot of things. There are a lot of technical things about Debezium, change data capture, but also we have these 3 key takeaways. I think that we need to extract from this in this presentation, and are more at high level, because you have when you are designing architectures, you need to pay attention on these 3 points. It's quite obviously, but you need to keep in mind these 3 points. The first one is more technical, but I mean, not so much. I mean, if you want to have a near real-time infrastructure, I mean, it's awesome to have data in near real-time, but you need to pay attention on the fact that if you activate the near real-time features, most of the cases you can have some, you're increasing the requesting of resources, and the underground processes increase, so you need to pay attention a lot of this. And the second key point is that when always when you are designing architecture, is that if you don't have in an environment, a test environment, I mean, if you have a test environment which is very, very different of volume than the production environment, it can be hard to elevate to design architecture. You need to find another way to test the infrastructure that you have designed, because it's really fundamental to have this. And the third key point is that you need to understand at 100% the skills that you have inside your team, because people inside your team will be the people that will maintain the infrastructure. And yes, you need to, when you are designing an architecture, you need to pay attention on which skills you have. And that's the end of the presentation. Feel free to ask any questions. And we are Marco Santoni from TeamSystem, and I am Andrea Romeo from Platform Engineer. If you want, well, I don't know if we have time, maybe not, for some
4 minutes.
questions. If not, you can feel free to take our contacts and write to us, text us.
Thank you.
Thank you.